Hello, my name's David Gill. I'm a software developer, and one of the open source projects that I work on is a game client called Parthia that connects up to an old text game called The Eternal City. I'm going to be making a video on how I get the information needed for this map. This video is intended to be for schools if they're interested in academically evaluating me. There's a remote chance maybe other people, if they're working on a client for the Eternal City, maybe they would want to reference it. And then also maybe employers, maybe they would want to use this for just general skill reference purposes like the schools. But so what I wind up doing with this game, the way I wind up drawing this map, we're going to keep in mind this is actually a text game. So you receive everything as text. We're not receiving these images. This is only text that we're receiving from the server. And actually, to be quite literal, it is a telnet server that we're connecting to. Unfortunately, it's not that simple. We won't go in depth on it. Even that portion of it was a technical challenge to overcome that initial connection because it's not a simple telnet server, but it winds up functioning. It is a telnet, not the standard port. And as you'll see here shortly, you don't wind up receiving your text messages in the way you would receive from a standard telnet server. So what we're going to do here is when I'm doing something in this game, we have this nice, easy to read text. Um, that's actually not, however, how text is received from this game. So I'm going to turn on my debugging window. This guy's a pop-out window that we can resize. I don't want to dock it, so I'm going to expand it here. And then what we're going to do now is how we just looked and how we just took a walk. So you'll see here, you'll see some information there, the shimmering gold doorway. Um, but we're actually receiving these with HTML codes. Okay, so there's that. That was a technical challenge to overcome. But let's take a step out of our road. So we wind up receiving this text, and you can see here I filtered out some of these codes so that we have nice coloring, and actually, even though this is all that we're receiving, I'm actually even have information. You can click the walk there. So these are actually also turned into clickable links. But you'll see here, these don't appear on the screen at all. So what happens in the two that we're going to be focusing on today are these two. I'm going to tad bit from memory, but if I recall correctly and looking at the pattern, yes, okay. The Scoot 6 actually tells us how to draw these rooms. Tells us where to draw these rooms, tells us the size to draw these rooms at, how many of them, and what color actually they are. It even determines the color. And then the Scoot 10 here, this is gonna this is gonna tell us actually how to draw these exits. Black exits mean that it's a door that's locked or closed. Closed, possibly locked, or just otherwise not available. But there's an exit there. And one thing I would like to point out is as I've developed this, I've had no coordination at all from 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 the host. So the only thing that I've received from the host is this data that you literally see on the screen. So I wound up literally looking at these messages, and I wound up literally determining the patterns of these messages on my own without any assistance. After I had figured it out, I had wound up shortly after finding out there was another client that was open source. I could have read and at least gotten a general idea, which would have been immensely helpful. I did not wind up doing that in this case. So what we're going to do here is we see here we've got this pattern. I'm going to move this away. It's not going to be terribly important for the next steps of pointing out how I overcame this technical challenge. This is the IDE for the application that I use to develop the client. The application that I wind up using is called Mudlet. And the reason I chose Mudlet is because it had a lot of platforms already available. For example, if we wind up going back to the application, for one, it already provides me the Telnet server, Telnet client, so I don't need to actually write a Telnet client on my own. We can see here these windows that I draw out; those are done with labels, so I actually don't need I don't need to do the work on my own to make those labels. So there's a lot of information that are a lot of tasks that I didn't need to do all the programming for beforehand, which is the reason why I wound up choosing to use Mudlet. So what we have here, we're going to go back to this, and what this winds up doing within Mudlet, you have something called a trigger, and when a trigger occurs, you can tell it to occur when I see text on this received from the server. In this case, I'm telling it whenever I receive text that the start of the line starts with scoot 6, just like what we had seen. And in this, I'm going to move so that way because I can see here I've got some move or some positioning, font, change size data. So we can see here that there's that scoot 6. That's the start of the line. Scoot 6 is the start of that line. This is just something I've put in just to determine this is an unfiltered line, so it's easy to reference. Scoot that back over again, and then we're going to bring back up that editor. And so what we're saying is every single time that we wind up receiving that message, I want this code block to execute. Now, Mudlet is written in C++, but it has an engine that runs Lua scripts. Lua is a programming language. It's most of the time it's only wind up used with games, and its only intention is to make it easier to do certain engine tasks within a game. So one thing I'm going to point out is to avoid needing to redraw a label every single time the person walks from one room to the other. I actually make these labels um, when the client turns on. I make all these labels, and I don't delete them or destroy them. They all stay there. In here, there's 150 labels. And what I wind up doing is that once I receive that scoop message, I go through all 150 of those labels for 150 exits, 150 rooms. I hide all those labels. Labels just basically being a piece of graphics that we want to show on the screen. And within Mudlet, you can determine its size, shape, or maybe even just make it be an image, which is actually what I did for the exits. So then I have I'm resetting a loop counter, and then what I'm doing here is I'm calling a predetermined function, and I'm just saying I want to call this function. The rest of this information here is actually for something far more complicated. I'll go into this in another video, but what I've actually done is um, I've made a much more complicated mapping system that keeps track of where the user is walking. Now, we're not going to go too depth on it here. We're going to focus back onto just turning that pattern into that map. So we see here we are hidden the labels for performance purposes, and then we're calling this function. So we're going to go into our script section of Mudlet. Here's this function, and I've I've added notes so that I would not wind up forgetting everything about how those patterns function. I'm not going to go too terribly in depth on it, but you'll just see, for example, I'm going to tad bit from memory here, but it looks like that's the X and Y position um, of the room that needs to get drawn. So that little square that would wind up appearing, it determines, I think the top left position of the square is that X and Y we pointed at, and then of course this is that scoot 6 message. And then 80 in this case is going to be the size. I think 80 is the max room size. I'm just going from memory there. The next number is going to be the color we draw it in. So actually, I know this one's red. So this is going to be that message um, is going to wind up being for the room that is red. So if we drag this over here and I take another step in another direction because I had size changes on displays. So these debug messages appear. Um, we can see here's the positioning of the red room. And the red room is size 20 and it's color red. So on this map, so at -10, right there, and it's telling it to what we want to draw it size 20. 20, by the way, is not pixels. We're going to get into that here shortly. Now this last pattern, I don't use it. However, it's the light intensity in the room. I probably should write it in, but basically it just winds up shading these squares differently. So now that we have a general idea of the pattern, what I'm going to wind and then what happens is I wind up looping through every single one of these, and then I draw the rows. But we'll get into that here shortly. Um, from there, I wanted the ability to be able to um, to resize the window that was displayed. So when we're positioning the rooms, the way we receive the data is the game assumes that your map window is 240 by 240 pixels. And then it actually, if I had a map window that was 240 by 240, and I never ever wanted to change its size, I actually could go by pixels on these and draw it without anything extra needed. What I wound up deciding to do is I wanted the user to be able to resize those windows to make them bigger, make them smaller, however they wanted to be able to actually use them. So instead, what I wind up doing is I convert those into percentages based off of 240 by 240 um, sized draw area. And then the other thing that I would wind up pointing out is just to make things a little bit more frustrating to work with is that the X and Y on this wasn't like your standard when you receive X um, like 0, you don't wind up necessarily having it be the center of the screen like you would wind up expecting. If I remember correctly, X0 and Y0 is the upper left-hand corner, not the standard grid mapping, where X0, Y0 would be the center of the grid. Um, it's the top left-hand corner. So what turning those all into percentages allows us to do is I'm going to now do this. And then one thing you'll notice is while the rooms resize perfectly, I did not write into the equation that while resizing, I didn't write in to actually redraw these exits. It was going to be far too cumbersome. So instead, I just wound up saying walk to realign exits. So we're going to just take a step. We'll see here, now we've got a window that's far bigger than 240 by 240 pixels. So we can actually, it allows us to adjust this right there on the fly. So let's go ahead. Now it's smaller than 240 by 240 pixels. And then we're going to wind up taking a step. It's just kind of a general, like, this is why I wound up doing that, right? So get it back to like standard size, and then let's take a step. Um, Now the last item is or for the rooms, is we're gonna kind of briefly cover. This is that actual function. So what I'm doing here is in Lua, um, for some reason, performance reasons. That's what it was. Instead of using regex, the Lua actually has its own pattern system. You'll notice this looks a lot like a regex pattern. I think it was modeled off of regex, but instead of /d for digits, it's %d for a digit. Um, I believe the negative, I believe in this case, there might be a negative symbol behind it. That's what the negative question mark is. I actually don't even remember if that's a standard regex pattern. The comma for the comma that appeared there. So what I'm doing here is every time I capture this pattern, I'm gonna do a loop. And what's happening is I am doing this off of line, which is which is basically the current line that the Mudlet client has wound up receiving. So so I'm doing this off of the line that Mudlet is currently receiving, and that's happening from that trigger. So when I receive a Scoot 6 line, I'm calling this function, and then I'm looping through the data in the line, and I'm telling here's my X position scalar, here's my Y position scalar, because I'm doing by the size of the actual map. And actually, I had written in Zoom. I don't really use the Zoom feature, but it's there, um, and I might be a feature I'll wind up using later on. And then I actually have a function that winds up calculating the general size scalar, how I want to like scale at which I want to change it, and then it goes through and it actually programmatically does the math for me. I can see here I'm moving this label, so I'm doing the label by that loop counter that we were set before, and then I'm resizing the label. So I'm moving a square, and then I'm resizing the square, and then I am basically going through, and I'm just going to skip to the bottom, which is where I wound up. I show the square, so I'm moving it, resizing it, and then once I'm going through, and looks like I'm also move, yeah, resize, and then I'm going through and getting some additional data like the color of it, resetting the color of it here. Okay, and then I see that this information in the center here is actually for that more complicated mapping system that I was mentioning before. So we're not going to go into that here. We're going to skip it. But for the purposes of that map that we were showing before, we resize it, move it, we change its color, and then finally we show it, and then we increase the iterator, we go through, we do it again for the next pattern that we wind up finding. Um, and then what we're going to wind up doing is we're going to cover this one much more brief, but we're going to go through the exits. So whenever a scoop 10 message is received, we wound up saying we want to remove the line from the screen. We're gonna here's a loop counter for the exits. We're gonna draw the exits, um, and then we're going to go through and resize. Um, okay. I'm lowering the back to make certain that it looks like sometimes the back must have wound up appearing. The back of the display must have appeared over. Um, and then there's some information for that more complicated mapping system we'll get into in a different video. But so the main thing is here is that we're calling this function. We're going to go over here. There's that function. Now, this message, these scoop messages, the scoop 10s, are considerably easier to read. Um, you've got the position of it. Here's the position of it, and then its direction. Is it horizontal? Is it pointing northwest? Is it vertical? So up and down. So it kind of gives us the direction that these exits need to appear here. And these exits again are those little white or black lines. Um, so if we go sneak back over here, here's a quick layout of how the exit gets drawn. And again, same thing as before, I'm looping through that line that we received when the system receives a line of text or a message that says scoop 10 before it. And then that line is that line that we're receiving. We loop through each time this pattern occurs, and then we're basically we're going through, we're resizing the exit that's getting drawn on the fly. I'm doing the size of the exit. I'm resetting the way that exit winds up looking, and then I'm going through and I'm changing the width on it, and then I'm basically going through changing how it's scaled for the purposes of a different size map. And then finally, I wind up max exit loop count. And then finally, I'm going through and I'm moving it into position. I'm putting it below the rooms here with that lower, and then finally I'm showing the actual map exit. And then here's this is just a little information for that more complicated math system, and then we're iterating. So for something that winds up being just sits there and you view it a lot while you're playing the game, but it's the effort that winds up going into creating it can can wind up being a lot, but admittingly also it wound up being quite a bit fun to be able to go through and do everything for that. But again, my name's David Gill. Um, thank you very much for your interest. If you have any questions, I'm going to include Parthia's Discord server invite link. My handle on Discord is Dave with a nice hat. You can feel free to send me any messages. I'm not avid on checking Discord, so it might wind up being a week, could even be a month, depending on if I'm doing something with school or actively work on vacation, and so on and so forth. But again, thank you very much for your